Hello. In this section, we'll be looking at further questions on trigonometric functions, and now let's look at this particular question. The question says that the integral of sine 3x cos 3x dx. Majority we apply integration by part. Yes, applying integration by part, there won't be an end to this particular question because you keep on integrating by part. Inside that integration by part, you apply integration by part again till infinity. Sure you get. So the best way to solve this particular question, looking at the question, let's go back to trigonometry. It looks like factor formula. This is factor formula of a product. This is product, this is multiplying this. There's a factor formula that can convert it from product to sum. We call it factor formula on under trigonometry. Recall that sine mx, don't let me use m, let me use a, sine ax cos bx. This is product, this is one, this is another one. It's the same thing as 1 over 2 into bracket sine a plus bx plus sine a minus bx. Yeah, we call it sum, product to sum. This is product to sum. Likewise, also we have cos ax cos bx is the same thing as 1 over 2 into bracket cos a plus bx plus cos a minus bx. Okay, and lastly we have when you have sine ax sine bx, that will give us 1 over 2 into bracket cos a minus bx minus cos a plus bx. We call them factor formula. Now applying factor formula to this particular question, that's sine and cos, and this is for sine and cos. By comparison, that's x. By comparison, a is 3, b is 1. Okay, so if I'm to apply factor formula to that, the particular question will now be the integral of 1 over 2 into bracket sine a plus b. What is a? A is 3. What is b? B is 1. So that's 3 plus 1, 4. That's sine 4x plus sine a minus b. What is a? 3. What is b? 1. So 3 minus 1, that will be 2. That's sine 2x. So the question is in form of product, which cannot be integrated easily using integration by part, but using factor formula, we've been able to restructure the question to sum, whereby we can now integrate them separately, in the sense that we say the integral of this first plus the integral of this. So I can say it's the same thing as 1 over 2 the integral of sine 4x plus sine 2x. We can integrate sine 4x, it is easy. Likewise, you can integrate sine 2x. Then I can go into conclusion by saying my final answer is, when you integrate sine 4x, that will give us minus cos 4x over 4. But there's 1 over 2 outside multiplying it. That's 1 over 2 into bracket minus cos 4x over 4. If you integrate sine 2x, that will give us minus cos 2x over 2. So if I open the bracket, my final answer is equal to minus cos 4x over 8 minus cos 2x over 4 plus c. Final answer. Okay, so Those are questions on trigonometry function. But what if you have another question like what if you have a question like the integral of sine 5x sine 2x dx? Okay, looking at this is sine 5x multiplying sine 2x. So if I'm to apply factor formula, this is the formula that goes with it: sine ax sine bx. By comparison, a is 5, b is 2. So I can apply this formula, but anywhere I see a, I substitute 5 there, and anywhere I see b, I replace it with what? 2, which I can say is equal to 1 over 2 the integral of cos a minus b. A is 5, b is what? 2. That will give us cos 5 minus 2, that's 3x, minus cos a plus b, that's 5 plus 2, 7, 7x. So if I integrate that, I have it to be 1 over 2 into bracket. If we integrate cos 3x, that should give us sine 3x over 3, minus, if we integrate this, that's sine 7x over 7, which is equal to, if you open the bracket, I have it to be sine 3x over 6 minus sine 7x over 14 plus c. Final answer. So those are other questions on trigonometry by trigonometry functions. Okay. Let's try to look into another question, which I can call it change of variables sometimes. Still on trigonometry function. Let's look at this particular question. Okay, the question says that the integral of sine cube x cos square x dx. Okay, now looking at this question, let's solve. Okay, I can say I have to change the variables so that the integral will be very, very easy, because this is integration of trigonometric function by power, and it's not easy to integrate by power. So I have to change the variables so that to integrate it will be very, very easy. So I can say that let u equals cos x. Okay, so if u is equal to cos x, I can differentiate that by saying du dx is equal to minus sine x, comma, therefore dx is equal to du over minus sine x. Okay, now substituting that into my question, I have the question to be the same thing as the integral of sine cube x. U is cos x, and I'm having cos square x here, then that will be times u square times dx. But what is dx? Dx is the same thing as du over minus sine x. Okay, now this sine x will eliminate one of this. This is just part 3, meaning we have 3 sine x there, so it's going to eliminate one out of it, then we'll be left with 2. Okay, so I'm having the question to be, that's equal to the minus is a constant, minus integral sine square x times u square du. Okay, now since we have it like this, but don't forget, what is my u? My u is cos x. I'm having sine square x. Recall basic identity. There's a basic identity that says that sine square x plus cos square x is equal to 1. Therefore, sine square x is equal to 1 minus cos square x. But what is cos? Cos is u. So I can say, therefore, sine square x is equal to 1 minus u square. So substituting that here, I have it to be, that's equal to minus integral 1 minus u square times u square du. Okay, so if I'm to integrate that, I can open the bracket by saying it's the same thing as minus integral u square minus u raised power 4 with respect to what? U. So if I integrate that, I have it to be minus into bracket. If you integrate this, that will give us u raised power 3 over 3 minus u raised power 5 over 5. Okay, now if I open the bracket with the minus sign, that gives me minus u raised power 3 over 3 plus u raised power 5 over 5 plus c. But what is u? U is the same thing as cos x. So substituting that back, I have it to be minus cos cube x over 3 plus cos raised power 5x over 5 plus c. Final answer. Okay, so in our next class, we'll be looking at more examples on integrations. Thank you.